Hello guys, hope you are doing fine. So today we will covering system designs one part which is on cache. So if we talk about cache, it's a very important component whenever we are considering or whenever we are designing a system, which says like a cache is a piece of software or it could be a hardware which stores data, and typically this storage is to reduce network calls, and that is the intention or that is the main purpose of cache. So the cache is actually meant to, you can say, like save network calls. So if it does properly, then definitely it can improve your latency, right? So typically what type of memory cache or typically what type of memory it uses primary memory or RAM. So this is something which is where we need to talk a little bit. Whenever we are saying like cache server is using RAM to store their data, that means this is really very fast. Means whatever operation we will be doing on cache server, that's very fast. And because that's actually we are doing on top of primary memory or RAM. But at the same time, there is another thing, and that is it's very expensive. So that's why we have, as it's very fast and it's very expensive in nature, although we will use it to reduce network calls and improve latency, at the same time we will think about this point that it could be, I mean, we need to have a mechanism so that we can maintain not a large amount of data in cache. So there is some restriction which we are putting on our cache server, right? And that is like the data needs to be, the amount of data needs to be minimized. And whenever we are saying like the amount of data needs to be defined, that means there should be some policies which is going to be implemented to maintain this amount of data, right? And that is called cache eviction policies, right? So what this policy is talking about, this policy is actually ensuring that after a certain time we will keep only the relevant data into the memory, and we will delete or remove in a periodic manner and maintain a good or defined amount of data into the cache, and that is going to be relevant. So we will discuss cache eviction policies in the next lecture. That's not actually our today's topic. So today we will focus more on the how the cache data, what is how we are updating cache data, because there are one issues which comes with this cache, or not, I won't say issue, this is kind of a thing which we need to keep in our mind, that whenever we are using cache there is a chance that the data might become stale, right? How and why? So we will look into that thing more in this lecture. So it actually depends on the how we are updating our cache. But before that, we would like to understand what is cache hit, what we mean by that. Cache hit means when user or when someone is requesting data and that is found in a cache, that is cache hit. If it is not, when requested data could have could have been found in cache, but it is not the original data. So if a server goes down, our load balancer, what is going to do, if it is our load balancer and if it is our server, if this server goes down, in that case what that load balancer will try to do, load balancer will have to forward request to a new server. Suppose this is our new server ns, and load balancer, instead of doing this, load balancer forward this request to the new server. Now what is going to happen here, here the result is basically cache miss, right? Cache miss, because it won't find that data in this server. We are talking about server level caching, and that is what exactly going to happen. Now how we update cache data? There are three techniques when we are writing data into our cache. The first technique is write through cache. So we can say like write through cache. We will understand it, what does that mean. The second technique is write around cache. So write around cache. And third technique is like write back cache, right? So write through, write around, and write back. There are three different techniques. So first we will understand what is write through cache. As the name suggests, suppose we have the cache server over here, and what is going to happen, our request will go through this cache, and this is our database server. So the database server is going to be, whatever the request comes, the post request comes rather, that post request will update the database, will write something in the database, and whenever it is writing through cache, so it will write in the cache as well as in the database. And when the data is saved into the when the request is saved data into the database, which is persistent in nature, that means the data is not going to be lost. In that case, it is saying a success report, or is success is kind of true, right? So that means successfully we have saved that data. So this is kind of thing which we are doing when we are implementing the first category, that is write through cache. As the name suggests, you can see the picture also depicts that thing. What is the advantage of this approach? The main thing is, as you can see, like we have stored the data in the persistent database, and then we are saying yes, we have stored it successfully. So there is no chance of data loss. That's a big gain, we can say, right? But at the same time, we can say it could be a little slow, because we are saving data in two layers, and when we are saving data into the persistent database, then only we are sending back a message saying is success is true. Okay, so let's come to the second category. The second category, suppose this is our user, so this is category number 2, which talks about cache, write around cache, right? So in this case, suppose this is our user, and user directly talks to the load balancer, and the load balancer talks to the database server, right? So this is our database, and this is, we can say, like first request. And whenever user this is kind of a, you can say like write request, right? And whenever user wants to read something, that means get request, he tries to get it from cache. Let's understand it very clearly. So so he is trying to read any data from the cache. Now your question would be like, if the data doesn't present in the cache, then how is going to manage it, how is going to return that one? So if it is not there, he will go to the persistent database, he will fetch the data, he will come here and update that data into the cache, and then finally he will deliver it. Now you can understand it very easily. First time, if the data doesn't present in the cache, it will take time, but next time onwards he will find it in the he will find that same data into the cache. So next time onwards it will take time. So in case of read, you can say like first time it will take time, but next time onwards it won't take that amount of time. So now the question comes, when this type of approach is going to be very healthy, right? So as this model suggests, this is kind of a suitable model when you are doing write once and read many times. I would say like many times. So write is to read the ratio. If it is very huge number, that means the system, sorry, read is to write ratio is very huge number, right? So that means the ratio, that means it's a read heavy system, then only this type of approach is very suitable. For an example, if you try like tiny URL stuff, system design on tiny URL, then you can use this write around cache, right? I think this is clear, right? So now let's move into the write back approach. So in case of write back, suppose this is our user, right? User is trying to make a request directly onto the cache, right? So this cache server, he stores the data into the cache. This is a write request, and whenever he is trying to read, he is reading data from the cache itself, right? And as now this data is actually in the cache, which is kind of RAM or primary memory, which is not very persistent in nature. So eventually there are some job queues, or yeah, you can say like job queues are there, and there are some worker nodes whose responsibility is going to be update your persistent database asynchronously, right? Asynchronously. So this is kind of a model which is termed as the write back. That means category number 3, write back cache. So as the name suggests, you are writing it back, but you are making it asynchronous. So the advantage or disadvantage, first of all, advantage is it's very fast, because whatever you are doing on cache, and later you are making your persistent database active, but at first you are targeting your primary database, and that's a cache server. That is advantages, comes under advantages, but the downside is it's taking too much time. So, and sorry, it's very risky, right? It's very risky approach, because if you somehow this cache server goes down, you will lose your data. So it's risky in terms of your data storing, or there is a chance of losing your data, right? So for the timing, I think we will be I think we will end this lecture. Hope you guys will find it effective. If you have any comments, put your comment into the comment section. Thanks a lot.